thermometer was, it's based on this functional principle that thermometer was discovered and was brought into use. So the actual important principle of the thermometer, your mind was not going to go to zero to thermometer from here out. Simply to we have different types of thermometers, and they all have
If objects A and B, which are not
they use to measure the temperature of the body.
in contact with each other,
Thermometric properties. The thermometric property is the property that object has
to them too. Some of them can't really see the board.
So this is just the definition.
You people should not be shy of camera. Don't be, just calm down. You people are always shy of camera.
So the thermometer is basically a tool that used to measure the temperature of the body. So when I said thermometric properties of the thermometer, they are the properties of that object that makes it function as a thermometer in that particular instance. Then I will list some of the properties of different types of thermometers available.
So all this is basic knowledge. So he's listing the properties of a thermometer. All those properties you look out for when you are taking temperature measurements. So these are things that we have done before. So like knowing the length or volume of a solid can tell you the temperature of a body. So these are properties of the substances used, liquid. So these are properties of substances used in a thermometer. So if you use a mercury now, there can be an increase in volume because the mercury will continue to rise in response to temperature. Same thing, solid can change shape when you heat. And you know that when you increase temperature, the pressure of a gas will increase at constant volume. So those are the things you're listening out now. So the properties of the substance used in a thermometer. So you can also use the volume of a gas at constant pressure. All these are still the introductory parts to Physics 103. They are basic things we knew before.
We have this in our mercury.
It's just trying to quickly store the basic definitions that we know before we now go deeper into new things. So if you use mercury in a thermometer, the mercury will respond to temperature and the mercury will start rising. So that's what that part is saying. So you can use mercury or alcohol. I know the advantages and disadvantages of using mercury and alcohol. So then for the length of a solid, you should know that's really talking about expansion. Expansion can take place in response to heating a substance or a solid. So same thing for a gas. A gas expands on heating. All of these things we are going to be talking about. So talking about sobaric. Can I ask you, you said they asked that in test that which property of the substance use color. I think these are still basic jam questions. Use color as its property. And that is optical pyrometer. So that's why it's just quickly listing them out because those are basic things. So then thermocouple, the properties electromotive force EMF of a thermocouple can also be used for electric thermometer. So by now we must have listed those properties. So just a summary of the properties of the substance used in a thermometer. So I hope you can write now. If you can hear me and you can write, you can also leave a comment.
No, it's okay. Yes.
Most of your questions are
So the
objectives.
science courses, even exams,
Everything was OBJ. Yes. So if you are writing yours, so everything will be OBJ. Most likely.
it's only maths that is not.
Yes. Maths is theory. Our funniest thing is maths. During tests, they will not tell you to solve. They will just tell you to leave your final answer.
Yes, that's it's German. So
It's
like
German.
you have the question, then you have the
No options. So that's why it's difficult at times. So if you solve,
you know that you see the options. Even if you don't know, you have to guess. If you don't know it, you don't know it. There's nothing you can do.
values,
Because a lot of people mix them up. So ice point.
values,
Because a lot of people mix them up. So ice point to 73.15 Kelvin.
Kelvin.
And triple point control by to 73.16. Just put them in your head. You don't need to stress yourself.
So in exam they can ask you, especially the units.
Most of them are straightforward. Just listen and doing instructions. And whenever if you listen in class, you not just like you attend classes, so you listen. Because some of the tests some of the questions on the tests are things that you have just seen in class. And as whenever listens to it and grabs it and applies it out. Sometimes you don't need to read it. Just listen in class, then it's like
So we are talking about temperature scales now, and so the temperature scales and the characteristics of temperature scales. So you have the Kelvin scale. So the Kelvin scale has the ice point as 273.15 Kelvin, and the triple points of water. Triple points, you all should remember what triple points is. So the points where the three states of matter coexist is what we call the triple. The gaseous and solid states coexist in equilibrium. So the states at which the three phases coexist in equilibrium is what we call triple points of water. So in exam in UI, they will ask you directly that what is the triple point of water. Don't make mistake of that value, and be careful of the units, Kelvin or degrees Celsius. And they can ask you in tests, and they can also ask you in the exam. So for the Celsius scale, Maddy, don't cry. Oh. Maddy is crying already. Nah, each one is 0.16, 0.15. Don't cry. Just know it. We have talked about triple points before. So it's just to know the value, and you can see it in tests. And they always like to set trap for you. So just be careful of those traps. So this is the Celsius scale now. And these are the units of the Celsius scale. So you have 0 degrees Celsius, which is the ice point. And you have 100 degrees Celsius, which is the steam point. At 760 millimeter of mercury, that's the pressure. So just know all of those things. Maddy, it is true. Hello, Maddy. Hello, everyone. So this is the unit conversion that you have to know.
so we have a temperature in Kelvin and you are asked to
The difference between university and is just basic things. So you can convert from Kelvin to. Yes, now you have to make use of everything.
in uni, we use accurate values. Most of the time in O-level, they use approximations. But in uni, you have to like, you know, a lot of people are not seeing this one before. This is what I use. So that's why you ask, because this is what you're familiar with. And this one, 0.15, is very important.
Is it possible for them to ask in Celsius? Like, the ice temperature?
Yes.
Yes, that's very easy. So
You can ask even for that triple points.
you can ask you in Kelvin. So if you Kelvin and want to convert to Celsius, just subtract the temperature again from this one. You get in Celsius. You get in Celsius. Add that one value to this, and you get your cycle.
So let's share this live class on every group. So all of you online, Please, let's share it with everyone. Akintunde Paul, Wanja Luka, Duchess Maji. So these are still the introductory parts we need to 103, just to make your life easier. So the Fahrenheit scale now, right? No, they are not So these are the scales in Fahrenheit. So you have the highest point, which is 32 degree Fahrenheit, 16.212 degree Fahrenheit, and 760 millimeter of mercury. So sometimes too, they can just relate it with any other units of pressure and ask you to convert. So just get used to them. So this is the relationship to convert to Fahrenheit. Just note those formulas. Most questions, the questions are always direct. They can just give you, this one even came out very well during our tests. They will just give you something in degree Celsius, and they can even write the formula like this to test if it is correct. So just note these formulas. This is the major aspect they will ask you questions. For Celsius. So where can you solve questions from? So someone is asking online. So there are a lot of past questions, and even in the slide too, there are questions. So it will solve some questions with you. If you do not have the slide, please let's work with the slide and past questions. So if you do not have the slide, please request. We will send it to the group. So for 103, we'll send it. Then we'll send the past questions too that we can still gather. Then we'll send the Google Drive. Then Dr. Movement has gathered some questions too. So you can reach out to Dr. Movement. So you can have access to most of those questions. But the moment you can solve all these questions, entering by March will be very easy for you, because there's nothing difficult, sincerely. Most of us, when we came in, we were deriving all these things ourselves. We were working on it, but it all came easy. Yes. No, they will just tell you, they will just give you the value in degree Celsius and ask you to convert it to. But it's always time. You have to be careful in UI. You might know upper and lower and all of those things, be using your interpolation method, but that might be too long. This one now you already know, just get your answer. So don't go difference in clinical is equal to, if you remember, I've forgotten. So the question says, find the difference of two temperatures, 40 degrees C and 90 degrees C is in Fahrenheit. So it is called change in temperature, so the difference. So he has gotten the temperature in degrees Celsius now, which is the change in temperature. Then that has been converted to Fahrenheit. I think that formula is just, I can't remember. So do you all understand how you have solved this question? Find the difference of two temperatures, 40 degrees C and 90 degrees C in Fahrenheit. So what he did was to look for the change in temperature, which he got 50 degrees C, then he converted it to Fahrenheit, and he got the answer to be 122 degrees Fahrenheit. So you will see more questions online, but it's still solving with you. So these are the questions on the page, on the group. So this is another question. So after this class, by 4:30, you'll be starting Maths 102. so you can share with others so that they can as well join the Maths 102 class.
So you guys try this out.
You have Fahrenheit. A pan of water is heated from 70 degree Fahrenheit to 175 degree Fahrenheit. What is the change in its temperature on the Kelvin scale and the Celsius scale?
I said you should try this one.
So you people should try it. Leave your answers in the comment section. We have quickly try this on your own. So let's see your answers in the comment section. You have 2 minutes to try it. I hope you can see the board. So I'm waiting for you to try. Give us your answers. Yeah, let's see who has gotten the answers online.
And tell me.
So these are past questions, and these questions came out directly in tests and also in exams. Hey everybody, what did you get? Are people no longer online? We are waiting for the answers of the rest. So.
Your first answer.
330.7.
Someone got 90 degrees Celsius and 363 Kelvin. And someone got 35 degrees Celsius.
I don't know if now, so what's your Celsius? What's your Celsius? 40.5.
Celsius are 40.5. So 40.5 plus.
How did you get to 330? Sir.
Yeah.
Let me see. Yeah, the difference is about 7. Right? So it's like Yes, it's one of them. You can look at something like that. It's the same thing. For the Kelvin scale, all of them are Kelvin scale.
330.7.
Sometimes they might give you a question where you give you the temperature range and you ask you the best form of thermometer to use in that context. So whenever you see this value, mercury. These are the values that mercury can test. If you see something below this figure, you already automatically know that mercury thermometer cannot be used in that way. It is above 350 degrees Celsius. So for this type of thermometer, looking in glass, the thermometric properties the length of the liquid. If you use any of these thermometers, this is the actual testing. The liquid, the length of the liquid will increase. So that's the thermometric property. They usually have to. Then
Solutions on the board.
electrical thermostats are actually the most accurate form of thermostats. Electrical. The only form of, only in some cases, gas thermostats. I will talk about gas thermostats. Gas thermostats, some forms of gas thermostats are more accurate than this. But generally, gas, but not all gases. So we are looking at generally, this one is more gas than this. Gas is the type of gas. This is really important. So you can see that's a much wider range. I don't think so. They think that's something like that. Well, in case you have what they might ask you is that they'll just give you a temperature and they'll ask you which thermometer you think can function in that context, in that instance. So if it's within this range, you can understand what to say. Within this range, you know this is the answer. Yes. That's why your conversion will come. That's why you have to practice the conversion. I think we should stop here. This should be like another thing in first class. This is how some people get it. So it works based on the resistance. radio function by what it's able to detect. That's why it's like that. It's able to detect very small change in temperature very fast. For instance, I said it works based on the resistance. But for thermoelectric, it works based on the electron.
You cannot see the board. I did all right.
And I'll send some questions to the president.
What this one they compare say dem no fit see.
Limit of x is approaching 0 from the right hand side. So start with
So now how do I check for this? As I said before, it does not mean it's exactly at 0. 0.1 is equal to okay, 0.1. This is so now if I do another very small number, also like big sharp. If I do another very small number like 0.01, that would like 1 over 0.01. That's 1. So if I do for like x 0.001, this number is still like very close to 1. That would be like 1 over 0.001. This is 1,000. So now, if we go for the right hand side, this is RHS. This is RHS. Then we have to do for LHS to check if this limit actually exists or not before we start solving. So now, check for the left hand side. Left hand side come from, so our like x equal to minus 0.1. If I do it for this limit, it should be 1 over 0.1 negative. That will be minus 10. They are not equal. Since they are not equal, this limit does not exist. You don't need to solve for it. So you can just put it like this as your answer. Okay. Your left hand side is not equal to your right hand side. You need to present this. And when something is undefined, it just means like let's say x. Let's assume x is equal to 6. Indeterminate. How do you know when you get indeterminate values? So for indeterminate values, know that when I was talking before, I said for you to solve the limit, you have to use direct substitution. So now, check if when you use direct substitution, then how do you know if you are putting an indeterminate value? When you have when you use your direct sub, then you get something like then you get 4 then 7 then this is it's just indeterminate form. Indeterminate form. I have 1 raised to the power 0 infinity by infinity 0 by 0 infinity by infinity.
Your answer to be indeterminate, to be undefined, to be that it does not exist. Yes. You will know from your answers. So, and those are the methods you can use to solve limits. Direct substitution, factorization. So they will always give you, that one is said there now that limit x tending towards 0 positive. So what is just saying that if you have a value that the right hand side is not equal to the left hand side, then you know it does not exist. So there are some negative values and all of those things. So this one I said limit with x tending towards 1. Here now if you do direct substitution and you put 1 as x, then 1 squared minus 6, then you will get probably a negative answer of something. So all of those things is what, so your answer will be what will tell you. So don't worry about all these rules yet. It might look confusing, but when you start solving, you will get it better.
So now, let's take the question together. Some of you already know the answers to this one already. So, limit of x approaching 1. How do I solve this?
Some of them have not done math before in their life. So let me put it that way. I know, but you did not know it. So what's like, even pronunciation now, limit as x is approaching 1. You must know how to even say those things. So don't say ewo ni lim, ewo ni x, ewo ni 1. All those simple things.
Sorry, I didn't know. This limit.
They are not math students.
So x
approaching 1.
This
So those are the values approaching 1.
guys listening?
Yes, sir.
So let's solve this first one. So x is associating 1. So anytime I see x, I need to.
You want to put 1.
So this will be 1 squared.
That method now is called what?
This is direct substitution.
Direct substitution. The first thing is direct substitution. So your final answer will now tell you
There are some
if you
questions
are okay or
that,
not.
that they are big, that you cannot be writing and then post direct substitution. Now the question I just need to check and just say like, okay, direct substitution will give me one of these. Then I'll go to, don't let know. So if you do this, this will be minus 6 plus 10. So this will be,
That's 5.
the answer will be 5.
So look at it now.
Do you understand?
Yes, sir.
So for this one, what's the first thing you do? Direct substitution. 1 is to power 20. 1 is to power 20.
Plus 2.
This 1 is to power still 1 minus 1.
Still 1.
So this is 0. So my answer is 2.
Another number is faster than
No, you cannot evaluate that. You cannot be doing like this. If you were to be like 2 now, 2 is to power 20. And you are not going to start with 4. They cannot give you something like this. If they give something like this, I don't want to get into this, but I want you to understand that. And this is like, x raised to power 20 this one now, if you compute it, if you do how we solve normally this now, what's the first thing you do? The x substitution. So when you do the substitution for this one now, you get infinity value. It's one of the that makes sense.
You know that infinity raised to that number will give you infinity because you get a very large value. That's what that word infinity means.
Do the substitution. Yes, you still get the infinity.
Just take your time, approach it little by little.
Let's take our
Now, this one that x is tending to 1, so the answer will just be 5.
So it's 5 that is right.
If you had gotten 0 as your final answer, I think that would be wrong, Abi. You should not get, that's undefined. You should not get 0. If you do direct substitution,
So you cannot just get 0 by 0.
0 by 0, so you have to now use factorization or rationalize.
So let's try.
Just know these things for now, those indeterminate values.
Yes, you have to know what to do there. Let's take this one. Let's try it.
So what did you get? 0 by 0. So you already know that's what.
Since you got 0 by 0, for some of us I don't get 1 by 1 squared minus 1.
So you should not get 0 by 0. So which means you have to simplify the question.
So now, if I do this,
Minus 2 plus 2.
minus 2 that's 0.
Minus 4 plus 4. That's 0.
So now,
So you can see your final answer now.
I got 0 by 0. It's one of the indeterminate ones. So now, since by using direct substitution, I go to 0 over 0. And 0 over 0 is one of the indeterminate forms. So that means I have to fall back to one of these guys. Yes. So I'll either use factorization, rationalization, or standard results method. Rationalization, when do you use rationalization? When you have like square root and like basically, or you cannot say any of this here.
So factorization will be the best.
Factorization will be the best for this kind of question. So now, if I use factorization method,
How many of you does not know how to do factorization?
so now,
So that's another thing. But the thing is, don't be scared, sincerely. Just try your best to learn basic things. You can learn on YouTube, you can learn, even if it is just to learn how to do factorization, you will quickly learn that. Before, the major reason, imagine you are at the resume school now, and your teacher, your lecturer just keep pointing, and you are like, how did they get here? How did they get here? So you can learn those basic things before you resume. The best, after you are done direct substitution now for limits tending towards 1, he got 0 over 0, and his final answer must not be 0 over 0. So he has to find a way to simplify that equation. And looking at what is on the board, what he will do now is that he cannot use rationalization. You also have to know when to use rationalization if you know about sort. But if you don't know, then what do you do next? Let me factorize. It looks like a quadratic equation. Abi, you know what quadratic equation is? Yes, so if it looks like a quadratic equation, so the best I can do is to factorize it. That will help me to simplify it. Then you approach that. So let him do the factorization. So if you don't really know much about factorization, you can try to work on that too.
how would I factorize it? How would I factorize it? So now, factorization, how do I write it in another way? That will make it simpler. Just one complex expression. So I'm going to be using the coefficient of this. Factors I'm going to use to solving this to factorize it here. So now I'm taking from this the value of x, sorry, the coefficient of x, I'll write it down minus 3. Then the remaining coefficient, which is a and b, which is this one, and this action as the b. Let's say we can put 1 here. It does not change the expression. So now I'll take the coefficient of a and the coefficient of x squared, the coefficient of x squared and c. I'm going to take the 12 and then I'll try to look for a way to get the coefficient of x, which gets on this kind of like this. The coefficient of x, you write it down. The coefficient of x is this one is minus 3. So you write it down. Then you pick the other two coefficients that we have in the expression. This is minus 1 and 2. So now this will be okay. So 1 and 2, guys. 1 and 2. So
what can you do to make it be minus 3?
what will I do to make this to minus 3? And when I multiply it, it will give me back this last this C. So now, if I do 1 times 2, 1 times 2 will give me 2. This 2 is the same as this one here. So now, how do I write this one? If I now add, you know that I already use positive 2 and negative 2. Okay, positive 2 and positive 2 to get this C that we have here. So if I add this positive 2 and the positive 1 together, so you get 3. And positive 3 and negative 3, they are two different things. So if I do not get negative 3, which is the coefficient of this x, I cannot use positive 2 and positive 1. So I have to look for another way to get positive 2 when I multiply it and negative 3 when I add. So what else can I use for this? I can use minus 1 and minus 2. If I use minus 1 and minus 2, minus 1 times minus 2, you get 2. Then if I add minus 1 and minus 2. Minus 1 plus minus 2. I'll get minus 2. So I have the coefficient of this one and the coefficient, and I used minus 1 and minus 2 to get the coefficient of this. And I used the multiplication of this to get this. So since minus 1 and 2 works and it gets the values of this coefficient, that means I can use minus 1 and 2. So it's minus 1 and 2 that will use to get the factorizable figures.
You are just rubbing everything. You don't even know if they want to write. So he's trying to look for two factors that you understand what he did. Oh yeah, you can continue.
So now, since I have minus 1 and minus 2. So how can I write this? That I'm not going to, when I still expand it, I'm still going to go back to it. So I'll have like minus x.
So everybody
Minus 2 plus 2. So now factorization is like, I need to put everything inside brackets to make it like simpler. So now I can see this one now. I'm dividing this into 2. So now there's something common between these two guys here. I have x here, I have x here. So I can factor out x here. So now x minus 2. Minus 3 is 1. So I factor out minus 2 here. I have minus 2 x minus 1. If I expand this thing back, I'm going to get this guy. So since these guys are the same, I can pick one of them. So now the x minus 1 and x minus 2 in the numerator. So now I'll use this like this. We're trying not to get 0 by 0. Which I already got 0 by 0 in the direct solution. So now if for this one too, I'll do the same thing.
wait, let them factorize that themselves. Oh yeah, what can you do to have two factors that will give you minus 5 and 4? That's minus 1 and minus 4, Abby. Those are the factors. She gets.
So x minus 1 and x minus 4.
Those are the factors.
These are the two factors. Like the factorization. So this can be this. So then we now use the limit of x approaching 1. Of x approaching 1. So if I put 1 wherever I see x, I'll do direct substitution with it. So that will be 1 minus 2 over
1 minus 4.
1 minus 4. So this will be minus 1 over minus 2.
Size.
So this will be 1 over 3. That's how 1 over 3. You get it?
Yes, sir.
Do you understand what he just did now?
Yes, sir.
What was the first step before he used this? He did that. Exactly. So you can see that that's the point. So how to now approach it to get this thing is the most important thing. So they can give you complicated questions. How to just do it. He has given you the principles already. So the only thing is that which method will I use to get it? And during our tests, the question came out that we are using rationalization. And a lot of people didn't get the answer still. So, but when he keeps on solving the questions, you will get it.
You might know what to solve and just like solve it. If you do, because it's German, if you make a mistake in one of the signs, even if you got the entire expression and when you were meant to do it, you added minus, you will get it wrong. And you're not even do anything for solving it. All those on account, they will tell you how the man will work is not life. They are no man.
Who has time to be marking all the workers?
So I guys know. Let's check.
And don't forget that your exam is German, so it is your final answer you will write. So imagine that your steps now, you went to write minus 1 over 3, and you have really solved, and your answer is 1 over 3. What's in law? That means you have missed everything. So this another.
try to solve it. Let's see where it is.
Just try to try different questions, please. And there are questions in that workbook. I don't know if you people have access to the workbook already. Please, you can always see all these things on the book. Number one, first question for 103. We already said if you can approach Dr. Movements. All of you should have had it by now. Olamide already has it, Sabi. So, who does not have? Try to get it on time. You already compiled all the 103. So, you will look for, most of our test questions will be there. Those ones promised did now, go and solve them. Those questions will come out. The questions in your slide, solve them using all those approach. So then the one, when you solve those past questions, then for maths is the past question and the workbook. Just go, there's a section on the workbook that is only on limits. So you go and solve all the questions on limits there. And apply sense. So now if you use direct substitution, what would this final answer give you? You check it out. Sometimes you have to look it with your eyes too because you might not really have much time.
Somebody do one part.
Zero by 3.
If you get to determine, you have to look for a way to
Make sure that it is determined.
when you don't try all that there's a little called
Olamide, indeterminate.
just allow it to say you can appreciate it. But that one is when you get to most times when you get to infinity by infinity and you already use factorization or rationalization and so on. You use the geography. So let's try to solve this one. So now let's look at this one. Direct sum. Use direct sum. This will be 1 minus 1 raised to the power. Have to look for a way to you need to rewrite it and factorize or rationalize or use any kind of so now
Don't rub it. Just write at the front that it's indeterminate.
so indeterminate we need to write it in another format. Now make it simpler.
So you have to think about the methods you can use now. It does not mean that you have to use factorization. You can use rational, you can use differentiation, L'Hopital's rule, depending on what you are doing. So, but you can try whatever method will work now.
So in addition, you have to look for a pattern on this. 1 over minus 1 over 3. Most times your questions they will give you it, but you need to not be like not be showing. You just have you need to look for it. Like just sit back and like check. Okay, sorry. 1 over. I can write 1 over. I can write this minus 2 over 3. I can write it in terms of this one. I'll make it look at like this. So now, 2 over 3. 2 over 3 is what? 2 over 3 is the same thing as 1 over 3. So 1 over 3. This will give me 2 over 3. So now in this case it is minus. So minus 1 over minus 2 over 3 can also be written out.
minus 1 over 3 squared. So
I can write x raised to the power minus 1 over 3. I can add the power. If I add the power, I'll still get back to this x raised to the power minus 1 over 3. This is now x raised to the power minus 2 over 3. You understand? So,
is that true? It's true. I thought the square would be like multiple. Okay, square of it, yes. That's good. Do you understand what you just did now?
Yes, sir.
You better talk. You can't tell your lecturer, so you should talk now. Toba we ko sọ pé sir, that's not correct.
so now, since I can write that as now the 1 minus x raised to the power minus 1 plus
1
1
minus
minus x raised to the power minus 1 plus 2. We agree that 1 square is the same thing as 1 square. Yes. So I can write it as 1 square. And we know the relation in mass, difference of the squares. So if I add a squared minus b squared, I can write it as a minus b squared
so a plus b.
and a plus b. So if I write it as this is the limit of x application of 1 minus x raised to the power minus 1 over. So in this case, my a is 1. My a is 1 and b is this guy. So I can just write this. What I'm just going to change is the sign that is between them. It will be 1 minus x raised to the power minus 1 over 3. And 1 over x raised to the power minus 1 over 3. So now I can write this direct. So when I use direct, so I'll have 1 over 1 plus 1.
Who got 1 over 2? She's not doing 102 now. It's 101 she's off.
So basically, the key to solving it is, can you see the difference of two squares that will make this cancel out so that I'm not getting this? Let's check the other one.
No, it didn't ration factorization. But you can see where the problem is. You know, in that first question, he saw it straight that he could factorize. But in this one, he didn't really see. But he had to think about it that, oh, they did something there. And what did they hide? Difference of 2 squares. But they didn't make that difference of 2 squares straight. So if you are looking at the question and you don't know your first step, it can be a problem. So now from there, what did he do? He first expanded, he brought out the square. So that we have 1 minus x minus 1 over 3 squared. But he now looked at it that 1 square is the same thing as 1. So seeing it that, oh, this is more like saying a square.
Same method, but you might not see, you might just rearrange it. Like this one now, they did not write it like this. You wrote it like this. Let me write it. Check out.
So you can see that math is all about if you have practiced enough questions. some things will be getting clearer to you. Hello. The noise is too much. So you can see the polynomial.
We try together.
Yes. Yes.
Wait, what's that?
You didn't give us time. You know how. Which one is it?
That was radio, yeah.
Okay, let me hear
Like the page. That don't make sense. Like the page of the answer.
So, what I'm doing.
What's the answer? Like the page of the answer.
It's okay.
Maybe I have another answer.
Yes.
The shock you. That X is intentionally X is pass.
You have another answer.
Yes.
Okay. So, say it now. You don't know if it was correct.
It's always different.
I should go with no.
That's it. He said, he said, Let's say now, you have any other. Really talk. Okay, let's have you written this? So now we have the problem here might be this. So when you try right, so what you get? 0 by 0. Everybody gets 0 by 0. So now you have 0 by 0. So 0 by 0 terminate. What do we do? We need to factorize. So how do we factorize? Since this is cube. So this just polynomial. Substituting mass 1 1. So how do I factorize this cube? Let me first, let's have this simple out. So this will be, if I factorize this is minus 8. What can I? What are the two factors? What are the factors? Plus 4 minus 2. Plus 4 minus 2. So that will be x minus x plus 4. X minus 2. You don't need to solve anything. Since we are using the factors and not equating it to 0. So your two factors that will give you this, since it is plus 4 minus 2, if you add plus 4 and minus 2 together, you get plus 2. If you multiply plus 4 and minus 2 together, you get minus 8. So we have 4. So now that means x minus 2 is a factor. It's a factor of this. How do we know that x minus 2 is a factor? There is a way to check. If your remainder, when you equate one of these factors, that you said, one of these proposed factors, when you equate it to 0. So if you do x minus 2 is equal to 0, then x is equal to 2. If you put this x is equal to 2, if you put inside this equation, if you get 0, that means what one of the factors to this expression. So this would be like 4 plus 4 minus 8. This is a factor. Since 8 minus 8 is 0. So that means x minus 2 is a factor. I'm so ridiculous is correct. So now, how do I do this? How do I do this guy? So now, basically, when you are doing polynomials and you need to like figure out the factors of expressions, most times you need to check minus 1. Instead of doing long division, that will take time. You can just check for, since all this we are not using like big values, you can just use minus 1, you can use plus 1, you can use 0, then at max you can use like 2. Then when you use like when you use any of these guys and you don't get 0, then maybe you now try log division. So now if you use 1 here, this will be 1. You get plus 7 minus this will not give me. If I use minus 1, this is minus 1. This is squared, so this will be plus 7. I'm not still getting it. So if I use 2 now in this case, this will be 8. This will be 28 minus 36. That means 2 is a factor. So now, that means what this is saying is that x minus 2 is a factor of this x cubed and this entire expression. X minus 2 is a factor. So now, since x minus 2 is a factor, so now that's I have one of the factors.
You are going to learn it. If you don't know how to do long division, there are principles, there are ways in which you can even make it very fast. Rules that you can do faster. Just try to learn them before resumption. All these are basic things you must have known before you resume, so that you don't spend energy learning long division when you are supposed to be solving some questions using long division. Remainder.
You don't have to go. Manual. It's only one of these factors that we are meant to be factors. So that's why we need to do division. So if you do long division, this divides this. Divided by x. That means x is past 3 minus 1. That's x squared. You guys get it? So this is x squared. So x squared multiplied by this x squared. This is x. This might be a little bit confusing, but you just have to check the finality. Then once you divide the first step by the first step, the questions like whatever is the remainder, you multiply it by the entire square. So if I multiply x squared by this one, I'll be having x cubed. So if I multiply x squared times minus 2, that will be minus 2x squared. So I can subtract from here. X cubed minus x cubed, that's 0. So 7x squared minus, don't forget this minus. The signs are very important. So if you do this will be 9 minus minus. That will be x squared. Then this is 0. 0, that will be minus x6. Remember. So if you do the same for this two, this divides this. I'll be left with plus 9. This was like 9x squared divided by x. If I cancel this, one of it will be 1, still left is 9x. So then I multiply this with 9x squared minus 18x. Yes, so this, when I subtract, minus 9 squared plus 9 squared, this is 0. So that's then 0. Note that the coefficient of x in this 0 x. This does not change. So if I subtract, then 0 minus 18. That will be 18. So that will be 18x. Then minus 36. Because 36 minus 36 plus 0 still minus 36. So now we do the division of this. So this will be if I divide this 18x divided by x. That will be 18, right? So this will be 18 multiplied by this. 18x. 18 times this minus 36. So this will be 0. So since the remainder is 0, this is the divisor and this is the quotient. So now we have another simpler quadratic equation instead of this cube. So this cube can be written as x minus 2 and
x squared plus 9x plus 18.
So that means if I multiply these two brackets together, I'll definitely get these guys back. So now we are arriving at something here now. We can see that this equation is getting simpler. I can quickly factorize this one 2. This will be what I factor. I have 9 and 2. If I use 9 and 2, I cannot get 9. If I use what I can use 18 and 1. If I use 18 and 1, I cannot get 9.
Can't get 9.
So, but there's one other, there are other factors too, 6 and 3. If I add 6 plus 3, I'll get 9. If I multiply 6 times 3, I'll get 8. So I can, since it's plus and plus, so I don't need to write the, so this will be x plus 6, x plus 3, over
X
x
plus
plus
the solution that you will write.
I will rewrite everything.
You will just continue from somewhere.
X application.
As a teacher, as a more ayaba.
So now, if you do a direct substitution again, that would be 2 plus 6, that's 3. 2 plus 3, that's 5. Over 6.
Do that size.
Mistake no day.
Multiplication. X times
You know the something. Guys, I'm not looking back on that.
My head is a mistake somewhere. Minus 18x. That is supposed to come to minus 18x and minus. Yeah. So that place now be like minus.
It's just
Minus, then 0x now. 0x minus 18. 0 minus 18. So you take to close. You get.
They don't stop past 3 lines. The thing is stop for 1.
that's what I was saying.
This is 7 minus 2. That's 9x. Then that's 9x squared. 9x times minus 2 is minus 18. How can I do it? So there's no square root of that.
It's correct side. The answer is 21.
Do you understand?
We know something. He says what he says.
8 times 5, that's 4. Plus 35 over.
It's what I said.
How you go taking the x minus 2? Can you quickly explain? So that will be no part. How will you the x minus 2 is never a factor?
Okay.
Now use 2.
So what we did is, we didn't this to 0, x minus 2.
No, that one, the upper part.
Oh, the upper part.
Like how you used 2.
Yes, we use 1, we use minus 1.
Yeah,
0.
you used
Okay, so
Snap
there
your
is,
notes. Then send it to the group.
during my work,
Snap
there
your
is,
notes. Then send it to the group.
during my work, there's no coefficient in x. There's no coefficient in
My physics is like, my physics is
upper part. So
my math.
I like to like, you may not, you do not understand why I just give minus. So 0 minus will give me. Yes. I guys all right.
That one you cleared the other time. Before you limit it. X minus 2. S squared plus 9x plus 18 all over x plus 4 x plus 2. Check out.
I'm saying that you cannot differentiate that the polynomials of God cannot factorize.
Use long division.
Like, no, that you cannot, even if you factorize it, it's not the same thing.
I don't understand.
How do I say it?
She wants to ask a question like a medical student.
No. If you have like this x cubed plus 7x squared minus 3, you know there's some equations there that you cannot
Factorize.
You cannot factorize. What will you do?
So
Use completing the square method.
okay, I try completing the square. Or most times it will not be like it will be probably like infinity. They will now do forceful. There's something they call forceful factorization. You will factorize the highest. When you are going to factorize the highest degree of x as the denominator, you factorize it out because I don't.
You will still see questions on that. So you see it.
I'll stay.
You have to be, you shall see questions. That's the type that came out in the exam.
Yes, that's the one that came out. Yes, if you get it, it's no other algebraic limits, non-algebraic.
Hey,
For trigonometry. Are we done right? Are we right? Sir, go to the
do you know the same condition that they are doing biology too?
And they are doing biology too.
Are you guys doing biology?
which biology you are doing?
It's just GES. They are not doing biology per se.
Doing all the biology we are doing. What they are doing and the math they are doing. Oh, yeah.
And you know they move everybody. Yes, all of them they are having 5.0 everywhere. Thinking that life is easy.
Like saying
That one is not for you. This is the amount of
question we send you that night. I don't start.
So now, this one looks complex, but you can solve it. So that is where you understand. So 11 is already so you are done right. You can take out this one before log x then minus 1. Like it's not one it's not like x minus 1. Log x then minus 1. Like it's not one factor.
Analysts.
Yes, you're coming.
I want to give them a chance.
Oh, okay. At the end of the day, wait, my name is Temi Dawo.
There's something in it. You know that. You don't make a mistake. You know that. Now you like I also feel this one. Next one is one. Let's do my plus x. Yes.
What did you tell me?
We're talking the value. We're talking about the calculator. Like, we're trying to expand this.
X minus 1, x squared plus 1, no, x squared plus x plus 1. He said, I don't know. I explained it like that. So it was, what's the answer? What's the answer?
What did you
What's the one? I believe in myself. The answer is, I'm waiting for you to say final answer.
No, like, you cannot say it, because right
The shape of that thing. The answer is 2 by 3.
I don't say, no, I don't get to what
It's 2 by 3.
Go to material.
23.
Yeah, that's what
Let's try it. Say it, sorry. Let's try it again.
I don't say it's police.
What do you get? Alright. Have you ordered?
Philip, you got so lucky. Philip, you got so lucky.
Lean. Do you know what's the So now, my confidence. So it's not like very you need to rearrange it for you to see. So now, what am I saying? I'm saying this x squared minus 1. You should be able to have something here. Like what that is difference of 2. So now, this should be limit of x approaching 1. But if I flip this one here, it should be x squared minus 1 plus x plus x minus log x over x cubed. This one now, how can I write this? I can write this guy as different of 2. That's x plus 1. So that's x plus 1, x minus 1. Like that, this question, this question. This question. So now in this case, A is x and B is 1. So you get x. Very fine. So now if I write x squared minus 1, I'll have like x plus 1 and x minus 1 plus x log x minus log x over x cubed minus 1. So now I can expand this one. This one's expansion